Okay, welcome guys to the stream. Long time no see. I hope you are doing very well. So this is my screen. I think I should make it bigger. Okay. Looks fine, right? Looks fine. Okay. Yeah, it's this Saturday morning. It is sunny day today, alhamdulillah. So today we have a good plan. Today we will talk about quickly we will go through the GAN model, through the encoder and decoder, through this CGAN, and we will try to go as fast as possible, but however try to understand deeply each of them. Okay, so I'm starting from zero shot as you. Previously I have tried to do the GAN model. It works, but you know it doesn't work as good as I expected, but it works. I can show you some examples from the GAN. So just give me some second. So where I put it? For them, it should be in the font, and then it should be in not here. Really? سيدي ناقش لي بشك. Yeah, ناقش لي بشك. Yep. Should be here. ناقش لي بشك means we have two GANs. Git status. Git pull. Okay, I have unstaged some stuff. I cannot show it, but DC GAN. I just deleted everything, right? Let's then commit. No. Git restore. Wait. Git restore staged file. Okay. Git restore staged. Okay. Then if I want to delete all this stuff, unnecessary stuff, then I should say get in touch. It should be something like this: staged, and then GAN, and then mnist. It's not staged, it's cached. I'm a bit confused, so what we can do? So I have a modification GAN in torch. git diff. Okay, my commit message is very bad. Changes in the. I mean, small changes. Git. Oh, if I don't mistake, no. I need to somehow remove this one. Those are untracked files. Wait, this is what we are carrying. I'm restoring it because I don't care, because the working code was in another computer. Okay, now we can easily say git pull. Okay, we have already update. Open. Let's see it. Why I am having hard time to open this ordinary file? Strange. So this is what we have, guys. This is what we have now. This is GAN model. So it starts from the nothing, and we slowly go to something. But you can see it is not clear. It is not as good as numbers, as original numbers. See, there are noise, but it catches a pattern, and we can see that it is somehow 8, 8, 0, but it's not clear. It's not crystal clear. So what may cause that kind of stuff? And you can see there is noise, like dots in between. But that was like my simple implementation of that GAN model. So first of all, we need to remove this stuff. So I want to say remove GAN MNIST generator and all. In that case, it should be removed, no? Yeah, it's removed. Discriminator, what? Discriminator? And then I don't like this GAN epoch. Remove GAN epoch stuff. Okay, good. I can congratulate you. Then remove RF GAN MNIST. Okay, now we are good to go. So first of all, let's go to CGAN and what does it have? Like, let's try to implement it. We don't have enough time. So the CGAN was introduced in 2014. What is there? What do they have? Guys, can you see my typing? No. Can you see now? Does it make sense? Does it make sense? What about now? Okay, maybe this is good. It's morning time, so we can do a lot of things today, inshallah. So let's go to the GAN model. It's Korean language. So we try to implement GAN. We use this linear layers and we use small number of parameters, but we use these two laws and two models together in combination, and we have somehow a bit noisy image, a bit noisy generated image, but it's working. It's working. It means our model learned to extract the pattern from the image. Like, basically it's working. So let's go through the code quickly for guys who joined later. So we have here discriminator. It is very simple, very small model. So see, we have 28 to 28, 768, 768 to 256, one matrix, and it has a bias, and then another one, and that's all. That's it. So number of parameters is not too big. It's very small. So here, how many parameters in this one in linear? 28 by 28, 256. 28 by 28 means that much matrix in row, and then 256, or vice versa. So that much matrix, and then plus a bias, So that much parameter we have here. So here, do you want me to estimate it? Okay, I will estimate. Let's go with Tmax. For guys who doesn't know what is Tmax, Tmax is good guy. He helps to split the window, and he helps to improve the productivity in terminal management. So here, let's say IPython. Oh, my IPython was broken. Still, I haven't fixed it. Okay, I have a torch. Then I say my model is equal to torch, and then linear, and I say 28 by 28, and what was another one? 20 by 28, 62, 32. 256. 256. Okay, we have this M, right? So in here, 28 by 28 is 784. 784 times 256 plus 256, is number of parameters in our this layer. So let me to prove m state dict. I can say for key value in that one, and then value do view -1, and then dot shape and 0. This should work. So it will basically calculate the total number of parameters. So this much parameter, and I need to sum this up. And if I sum it up, then I will eventually come up with this value, and which is correct, which is definitely correct. So yeah, this was small misunderstanding, right? So here we understood that this layer just has just a little bit over than 200,000 parameters. I mean, it's big, yes, it's big. But what about this one? What about this one? This one is 256 by 2 plus 2. It means 512. No. Maybe 512, right? 512, 514. See the difference. I mean, discriminator is maybe overfitting, or maybe there is some. I mean, it's very big number here, but we don't have another option because our images is 28 by 28 when we are using linear layer. So we can come up with using convolution layers to tackle this down. So in that spirit, if we continue, we will see that this one means what? 1000, 100 plus 100 means 25600 plus 100 means 7. This much parameter. And here, oh, this is big. It will be what? 768 00 plus 100 0689. And unflatten is there is no weight here. There is no weight. So 76 by 25, it means approximately 100,000. Okay, our generator has 100,000 parameters, but our discriminator has 200,000. See the difference. And there was a small problem I had. The problem was that we need to provide noise. In normal distribution between 0 and 1. Then this is code for training generator. Yeah, I need the initialization. It somehow helped. Then, but I'm doing this iteration, so that I think this works. This is very good to implement this one. It means we are training for several times, and then we are training several times the discriminator or generator, and then we are giving another several time to train the generator. So it's not like 1 and 1. It's like this guy studied like for 1 week, and this guy studied 1 week respectively, and another 1 week, another 1 week. So it's like that. So that's basically the point of mine is that our linear discriminator is this guy, okay? But we want guys, we want to play around and try new algorithms, new techniques, okay? So I think let it stay here. You can see my screen, right? Don't feel shy. Type on the chat. If you have questions, ask questions, because if it is a good question or if it is interesting question, I'm happy to help and guide, because If you ask question, it means you are interested. It means you want to know something new. It's good. So what do we have in CGAN? What is CGAN? Conditional. Conditional. Okay, let's guess. What can CGAN means? Conditional. There should be some kind of condition. If else condition or some kind of condition. I want to, I want today try this encoder and decoder also. So let me to write it down. Encoder and decoder, just simple encoder and decoder with convolution. Okay. Encoder and mirror decoder. And now, if we do CGAN, then style GAN, and etc. So we should go. Okay, everything is good, right? My voice, my audio, my screen. Okay, my hair is bad. Okay. Okay, this is our generator. Okay, in conditional, it's simple. They said, let's add some y, additional y argument. Let's decrement the generator. Class label as one hot vector. Okay. Max out layer. Max out unit. I haven't heard about this one. What does it do? We have linear. Max pooling. Okay. On squeeze -3. A bit confused. So we have max pooling where we have a kernel size and we take the maximum of from them. And max out means we are doing the same, but But then why we are not using max pool? Kernel size, number of channels, unsqueeze -3. Okay, this is a bit tricky. So basically, we understood that here we have two models, right? We have two models, and they are just linear layers or kind of traditional layers, traditional models. But as an input, we should give condition, new condition, and it is a class label as one hot encoder. Can we use it? Yes, of course. But the point is that here, okay, here, let me to go even further. Point is that here in forward we will pass, let's say, so this y also, right? And this y is one hot encoded vector, one hot encoded vector. It means the shape of y should be, you know, page size, and then what is the total unique number of classes in y? It is 10. 0, 1, 2, 3, 4, 5, 6, 7, 10. Yes, 10. So y should be like this, and x should be how? It's also be, and for generator need to have, what was it? So something like this, if I'm not mistake. No, 256. 256. Okay, this is what we should have in generator. Okay. So how can we use this y to pass through the x? So what they are saying, so it is generator, right? In generator net, a noise prior that with dimensionality 100 was drawn from uniform distribution. Okay, they are using 100, we are using 256. Okay. In CGAN, they use both Z and Y are mapped to hidden layer with rectified linear unit ReLU activation functions. Okay, so you are using ReLU. Okay. So what? With layer size 200 and 1000 respectively. For Z we are using 200, for Y we are using 1000. Wait. I am a bit confused. But anyway. Let's make a new deal. C linear generator. Okay, I'm introducing new module. Yes, I'm a bit nervous, sorry for that, guys. Self, I need super because I'm inheriting from the NL module. I know it's overhead. Then we are saying that we have rectified the unit, right? I don't care about that one, but self linear L1 x L1 linear layer L1. Let's say x L1 equal to nn dot linear, and it is 100. Do you want to stick with 100? Yes, we don't want to make any risk. So from 100 we are going to 200, and then self y, have y also. Okay, yl1 is equal to nn dot linear. We have what? It is shape of 10, and we are saying it should go to 1000. And then we are saying we will pass through the rectified linear unit ReLU. So how is the InTorch to activate? ReLU 1 was nn dot ReLU. Def forward. In forward we will pass self x and y. Then x equal to self x l1, and we pass x. Then y equal to self y l1, pass the y, and then we need to pass through the relay also. X equal to self ReLU x, y equal to self ReLU y. Okay, then we are saying before being mapped to the both z and y are mapped to hidden layers with rectified linear layer activation. Okay, with layer size 200 and 1000. You mean 2000 and 100, 200 and 1000 means 200 for z and 1000 for y? Before being mapped to second, combine. To second, combine hidden. I think we are in right direction, guys. If we are in wrong directions, it's not that big deal. L2 linear layer, linear 1 2 0 0, and we need to map it to 784 because 784 is the output. Okay, output. Then we said we have sigmoid. Sigmoid was something like this, right? Or do you want me to use like torch dot nn dot functional dot sigmoid? We can go like that also. Here xy equal to torch dot concatenate, and I pass x and y. In that case, what will be our dimension? So from here we will receive, you know, what will be? It's b and 200. From here it will be b and 1000. So we need to map in which direction? So we can concatenate when the dimension matches, right? Or not? So here I can have two options. I can say is either 0 or either 1. If I use 0, it doesn't make sense, because if I use 0, it means our output will be 2b. Yes, 2b, and it will crash. If I use dimension 1, but the numbers doesn't match, but b matches, so that it will be b 1 2000. Quick test. Import torch. We will quick, guys. We will be quick. Inshallah, we will be quick. So here, torch concat. Let me create a small tensor. Torch random. Let's say I have a batch of 2 and I have 200, and then Why it's equal? Who put equals? And then torch dot the rand, and then we have 2 but 1000. Okay, I made mistake. Because who puts here brackets? Why we need brackets? We don't need brackets. Dot shape. Okay, it doesn't match. It doesn't match. It doesn't match. Okay, we have a battery. So the shapes doesn't match. So it means it's a bit maybe wrong. We will fix. So finally, I mean, according to the papers, they said finally they use this after concatenation. We will use another ReLU. And then we will use but sigmoid. Do I need to do something? Do I need to initialize something? If I pass to 1200. Interesting. They are using sigmoid. I use a tangenus. And I say it in the end. I say it out dot. It depends on batch size. Why we are putting 1? Okay, here we have a small problem. I cannot concatenate in dimension 1. Let's read again. Okay, noise 100 is given to the dimension. Okay, both they have mapped to hidden layer with rectified ReLU. Okay, with layer sizes 200 and 1000 respectively. Before both being mapped to second, combined hidden ReLU layer of dimensionality 1, 2, 1200. We then have a final sigmoid unit layer as our output for generating 784. So let's go from the beginning. I mean, from the end, we have this one. It's clear. This is good. But when it comes to the concatenating, we are making some troubles, mistakes. Look. Both Z and Y are mapped to hidden layers with layer size. Mapped means we applied linear layer. For Z we apply 200. Yes. For this guy we applied 1000. Yes. You know, I think why they did is that because if we check it carefully, 100 by 200 means what? It means 200,000,000, 20,000, right? And if you check this one also, it means 10,000. Okay, it means, how can I say, this is half of this one. This one influence to the model half as this one. Basically speaking, not that much. I mean, that much influence does it has. Or am I doing something wrong? Wait, I may be doing something wrong. Maybe I'm still sleeping. Who knows? Voila, good, done. It works. This works. Really works, sigmoid works, unflattening. So we need to check it. So how can we check it? Simple, guys. So we say I know, I mean, this is ugly checking. This is straightforward checking, and it is very bad. However, for M, I need to pass two things. For torch rand n, let's say B is 1, and then 100, and then torch rand n, and then 1, I give 10, and this should give me output. I don't want to see the output actual, I want to see output shape and everything. So I will say here, you know, import. I learned this new good trick, you know, import pdb, and then pdb dot set trace, and done. And then we say write, and then we go here, and then we make like this. I created new window, small window, and then Python. Then what was the name of this file? Then it was GAN in torch. Let's go. We have some kind of small problems. There are small problems. Warnings. Oh, we are downloading something. I deleted something. So this is milk, guys. We need to drink something. We need to stay hydrated. We can drink milk or water, but we need to definitely drink something. Okay, now. Okay, we have a problem. No attribute radio. Yeah. I mean, this kind of small typo happens, and that's normal. Relay 1 sigmoid. What does sigmoid do? Sigmoid splash whole your distribution, let's say, to between 0 and 1. To something like that, right? Correct me if I'm wrong. Correct me. I think, what if I just do it ReLU, man? I mean, provide the size, don't multiply to upside of the, okay. Provide size. So after this, we need to apply, let's say, we need to apply self. Okay, this is my problem, guys. This is my problem. I am in hurry. I should not be in hurry. I should be calm. Okay, L2, X and Y, concatenating, and 784. And then this one is very bad, you know. B. P is equal to x dot shape 0. This is Jaidara, we call it Jaidara. Okay, done. Out shape should be something like this. Okay, good. Good. And quit, and I'm quitting this Python debugger. And actually, I wanted to do a video regarding how to use this Tmax, this terminal, because most of people are using this Windows. Very unfriendly, very, how can I say, locked, bound operating system. So our linear generator is working. So now let's try to implement the, or do you want to increase the number? Do you want to increase? Okay, let me to make it the experiment. I'm increasing number of patches, so it means as I increase the number of patches, it should be higher. Okay, dimension out of range. It's going to be in range of -1 and 1, but got 9. Okay. See, we have a small problem here. In unflattening, we have a problem. But why I am having problem? Maybe it's because I need to remove this unnecessary bracket. I need to read this documentation, guys. I need to read documentation. let's say I have a torch.rand. Let's say I have 9 multiply 28 multiply 28. Okay, I have this much vector, big vector. Okay, and I want to unflatten it in such a way that I have a 9 1 28 28. Okay, unflattening takes 3 positional arguments, but 5 were given. It means it means 3 means actually it's not 3. It means we can give 2. So if you don't know that one, we go torch tensor, unflatten, and question mark. No? If you don't know unflatten and I want to read the documentation, a good thing is that help. Type help and ask dimension and sizes. Okay, in that case, it should be 9, and it should say something like this. No, this is not a dimension, guys. Look, I am losing unflatten here, right? And it doesn't make any problem. But here, I'm using that and I'm having a problem. I understood. Because we don't have dimension 1 right here. But eventually here we will have dimension. We should have dimension 1. Actually, it's here. It's something like this one. Okay. And unflatten 1 means go to the dimension 1. In that case, it's not B. In that case, it makes sense. It makes sense. It makes sense. It makes definitely sense. Replace one, insert, and then, yep. Dimension and size. In that spirit, we begin. Good. Generator is working good. Congratulations, guys. So now let's try to implement the C linear discriminator disk and then module. I know I can copy paste, but why we need to make it simple? It would be too easy to do that. Oh my god, so many small mistakes. Super init. So here, let's read it carefully again. So we have discriminator map x to the max out layer with this kind of unit and 5 pieces. Okay, I don't actually know what does this mean, but we can check it out. So basically speaking, we have the forward, and so we have x and y, and here x is what, you know, and here x forward self x and y. I think we are making some kind of mistake. Okay. Now clear. So here our x is, you know, x is b batch size 128 by 28, and our y is b and 10. Okay, b and 10. Okay, then let's go through map x to max out the layers. Okay, we have max out, self max x max out, and we have y max out. Okay, I don't know exactly what does it mean, but it's written we have pieces and we have units here. Okay, we have some kind of pieces and some kind of units. Okay, and we are doing and what else? Both of the hidden layers map to the joint max out layer with two. Okay, and then concat another. And sigmoid. Sufficient power. Well said. Max out unit 6. Let's check to the 6. Good fellow. Max out networks. Good fellow, man. Let's go. I think it's good tactic to save this one. How to save it? seems broken. Okay, we have the dropout. So name it because it is output is the max of set of inputs, and because it is natural. Wait. So named because its output is the max of set of inputs. Okay, we have max pooling. Max pooling has a special kernel size, and based on the kernel size, it will get the maximum from the given this kernel size. So we have kernel size. It will shift it through the image or through the given tensor, and it will get the maximum, just one maximum, and build new metrics, new tensor. And here they are saying the same, no? Okay, let's go. This is max out. Guys, this is max out. It's activation. I understood it is activation. So here what we need to know is this one. Then do we have in torch implementation? Okay, guys, let's use the logic. Okay, let's say we are here, okay? We are in here. And one thing we need to do is that, anyway, x equal to x dot flatten 1. Why 1? Because let's say we have this new out input. Let's say this is x, okay? 128 by 28. This is our x, okay? And if I say flatten 1, it will take this guy and all other guys and flatten. Then if we do flatten, next step is to use max. But why is they saying they have units and they have pieces, but I don't see here any unit and piece. It's just I'm seeing is that we have Z and we have I and J. I to K, J. So in our case, it's just one vector, one long vector. And how can they, if we take max, then it will be very small number and it will be wrong. Figure 3. Then we need to implement the linear layer, right? It turns out we need to implement linear layer for them. What is max out layer? So he's saying now it's layer, you know, max out layer. Ah, that one. What the ugly stuff. Okay. Look. I made mistake. So this is not only this one. That is output of the output of this one. Okay, in that case, it's a bit simple. Seven, 6, 8. Then 768 or 784? 8864. 784. And then we need to move it to where? 240 units and 5 pieces. 240 units. And 5 pieces. 5 piece. Okay, I think I'm getting something wrong here. Peace. What does peace stand for? So what does max out do? So here we have let's say input, and based on input we do the linear layer calculation, and from the linear layer we will just take the maximum from each row, or maximum from each watt. So j is 1 to k. What is k? Let's look to here. No, it will give only one result. No. This means this one. Oh, that is 0. Oh, wait. We are creating several linear layers. See? We are creating several linear layers. And appending to the Z. And then linear layers, okay. Self Z layer input. Let me get Z. This is not important. And then h equal to torch max h by Z. So here we set h equal to none, and then we'll have several tensors of same shape, and we will try to get the maximum from this all. It's not as a max pool. No, I was wrong. We can do the same as max pool, but here they don't have this moving stuff, moving kernel. I am sanitizing my house. So how we can go? How can we go? What if I say to you to use something like this? 5. 5 means 5 pieces. Do you think it works? Do you think that this will give us a copy of this same 5 times? Because a nonlinear layer will return what? It will return an object. An object multiplied 5 times. It will be 5 times? I mean, let's check it. I don't know. Maybe I am mistaken. Yes, it's unsupported. So how can I copy it quickly? Multiply by 2? No. The what? Understood. Very simple, guys. Very simple. Alhamdulillah. So what we can do here instead, we can use list comprehensions. You know, fancy stuffs. So we can say this stuff, and then we can say for something in range 5. Okay, in that case, it should work. We should have 5 linear layers, and the same we will go with this y, and then dot linear. And if I don't mistake, in this case it was 15 5. Okay. Then I mean, maybe this is good stuff. Max out, huh? Maybe it will work very well, huh? Who knows? Okay, 240. We need to give input size, and then for something for nothing in range 4. Okay. Here, what will be our shape? 240 plus 50. 240 plus 50. And then we apply sigmoid. Guys, very sorry. I'm very sorry because I need to do sanitizing at house. So I think we implemented quite all of them, but now we need to verify. Okay. So here we have flatten, and according to the paper, this is linear layer. I to J. W is DMK. DMK, okay. And then max ZIJ. 1 to K. 1, 2, 3, 4. I mean, from here it does make sense. Wait. Am I missing something? Simply fit forward technology. okay, our W is DMK, B is MK, okay. But I to J, what is I to J? I to J. 1 to K, I to J. I'm a bit confused. I need help. Help. What we can do? I mean, when I check this one, see here, max of H, Z. I don't care about normalization for now. Input. For layer in self X max out. Is audio pretty bad on YouTube? I think I bought a microphone. Should be fine. Maybe you should check your internet. So max self X max out. Then it is a list, and for a layer out layer, I need to give X and X equal to that one, and then X equal to torch.max between X and out. Okay, we have 2 viewers. Congratulations. From the layer we got the Z, and if it is zero, we are saying we are not comparing, we are not taking the max, and else we are taking the max between H and Z. H means output, right? What I can do? I can say, like this. I can do vice versa around. Which is equal to X, and we get output, and then we compare with that H, and we get here H. This looks cool. Okay, is Linux bad? Wow, why is Linux bad? Linux is good. I like to learn neural networks and AI. Yeah, welcome. We are doing from small thing, so I think you can catch up. Max H and out, and then here we will get H is out finally, and then is in practicing Python, where should I start? As in practicing Python, where should I start? If you want to start Python practicing, you should go python.org and just read the documentation and do practice. Done. There is no secret. X max out and then Y max out. Okay, we have 2 viewers. Congratulations. So y max out, and then yes, I need to pay attention to my readability of my code and etc. and such kind of stuff, you know. So y, I don't need to flatten it, so I can say y is equal to layer, and then I can just pass y. It's better to assign y right currently. And I can say, you know, I can say y is equal to torch dot max, and I can say y or layer y, and then here I can say y is equal to self y max out 0, and I can give a y, and it should work. I mean, I think this is good readability, right? I mean, this is good. No, Python for AI, what library you are using? It doesn't matter. It doesn't matter. I'm using Torch now. Because it's output from Y. And then both of the hidden layer map to join max out. Okay, we need to concat. Torch concatenate x and y. Dimension 1. In that case, I will be b and 290. 240, 240, 290. Yep, good. And then last another x and y max out. So we can say x and y is equal to self dot x and y max out 0, and I pass x and y, and then I say for layer in self x y max out starting from 1, then I say x and y is equal to torch dot max of x and y or layer x and y. This is my first time using this max out, but do you think this will work? Because it seems like it will be too much sparse and layers may not work as expected. I mean, let's try, like, let's practically see how it works. And in the end, we are fed to the sigmoid. Guys, if I am fed to the sigmoid, the output shape will not be, you know, it will not be true and false. What is the shape of output? So out shape here will be, as it is, it will be 240. But we need, B1 at least, or something like that. Where? 67. On 67. Okay, we have a problem. In 76, is it easy to use Java for AI stuff? I don't know. I don't know. I haven't heard about people using Java for AI. Maybe there should be some kind of frameworks, libraries, but good standard is Python now. Torch. So here, look, from here I have X, right? And from X I have H. And what is the shape of H? B240. And why we are passing it to here? I think it should be this X. This should be X, guys. Yes, of course. Yes, yes. Okay, we have a problem where in 87 how it is in 794. Look, my X shape is 9 and 784. Yes. What is the HX shape? Shape is 9 by 240. Okay. So now HX is same shape. Yes. HY shape 950, something like that. Yes. So now X and Y shape is simply this one. No, why? So how? I am not getting it. You know. Wait. Torch.cat. I told you I'm in rush. I make stupid mistakes. But anyway, it seems like it's working. Yeah, 240, 240. What can we do? Let's do the sigmoid. Oh, softmax. Log softmax. On dimension 1. Actually, I should check now. Actually, what is their loss function? Okay, it's, when we check it, that one is loss is same. So I'm using this log softmax here, but I can use it behind there because there is no weight. But for convenience, I'm using it here. I've been battling with Prolog for last couple of weeks. I'm not quite catch up your level yet. Prolog. What is Prolog? Prolog. So okay, we have this out and we can try it, guys. We can try this. We will do very, very small change, you know. CGAN. See. I need to change this. My mistake. Small mistake. I play around with this one. I don't need. Seems like it's morning 8:30 in there. Have a nice day of killing bugs. Okay, okay. Yeah, I'm killing bugs because outside is now it's cold and the bugs coming to my house. Anyway, they just make me disrupt. So killing it. So have a nice day, you too also. So now let's try to run the model. Okay, we have problem. Optimizer got an empty parameter list. Okay. The discriminator got empty parameters. It means something wrong. Maybe we are missing something. Linear. C linear disk. Why it's getting the empty list? Because my discriminator is what? It has lists and it doesn't bound it to the torch reverse recurrency, right? I mean, it is out of the torch control because it is list. Because of that, it's having trouble. Yes, I understood where is the problem. Prolog is programming in logic, which I consider is a beginning friendly language to get idea about AI. Programming in logic is which I consider is beginning friendly language to get idea about AI knowledge base setup. Still, I didn't get it. I don't know. So I think you are talking about basic linear layers, or are you talking about logic units? Okay, so here our problem our problem arises because of these three guys. 1, 2, 3 guys. Because these linear layers are in the list, which is out of control, this NN module. So NN it should map to the NN module. So what we can do instead is, one way is just to do it manually. So let's try to do it manually. It will be something like x max out 1 equal to NN dot. I mean, let's make it not that much stuff. I can say 4 in the range 5, as we said. Self x max out equal nothing, and then let me to Google the prologue. I haven't heard about that one. It seems like new thing. Seems fun. Try to learn this one. Query 1, output yes. Two, 3, 4, 5. I think if I do something like this, it will be stacked with this self. So self is connected to this module, and it can do it can call dot parameters in Torch. So let me to validate quickly. Linear discriminator, print m, there's import sys Why I'm getting so many messages? What's happening? I don't understand. I don't understand Korean very well. Something happened at post office. Generator object parameters. Okay, it's working. It seems like working. Good, guys. That logic is working. Is valid. We should come up with better idea, but for now, this is quite good. Insert append 1, 2, 3, 4, 5, and then self dot y max out equal to okay. Oh, mistake. My fault. We need 4 of them. I remember. Or maybe should we try to do some kind of lead code stuff, guys? Maybe you are interested about that one. Is there any problems? We are missing something. List 1, 2, 3, 4, 5, 5. Let's check it. Let's see it. Okay, we have problem. See linear GAN missing 1 requirement position. Why? Of course, we haven't fixed the problem with why. I think the good thing is, copy GAN in torch CGAN py vim CGAN. Okay, guys, we don't need you. What? Okay. This is get noise. What is a data set? What kind of data set are you talking about? And why is this skipped? Ah, we already have data set. Torch labels. No. What kind of torch? Stack labels dot float. I can go to with label, but label. I need one hot encoder, one hot encoder, one hot encoder, one hot encoder. Torch. One hot. Oh, okay. Have a good sleep. Have a good sleep. For me, it's Monday. For me, it's morning, so I need to work harder. So have a good sleep. Model grill X, and then I need to pass Y. Okay. I need. By the way, I support. Okay. Very well. Very well. Okay. I do regularly this kind of live streams, and I think you will like it. You will like it. So like, congratulations. Have a good day. Have a good night. So model real X and Y output. So Y here's what kind of Y should be, and get generated. We just give Y same. Should we give same Y? Yes, and then here Y. Why? I mean, now the order will be changed, right? X I will get noise, and then I need to give Y. Okay, here's a good challenge. Look, I have a batch size, and I want to generate torch zeros. Let's say torch zeros, and I will say B is 2 and 10. Okay, and I need to assign one randomly to any place. Randomly assigned to any index of this one. In that case, it will be one hot, but I need to be random, at random. I think zeros is not good approach. What? What about if I say one hot and I give tensor. 0 and 10, and then page size, let's say 2. I mean, this is good. Finally. Minimum is 0 and maximum is 10. 10 means it's not 10, it means 9. And then I'm generating page size and number of classes equal to 10. Okay. Okay, now we have y train generator. We get real x and real y. Okay, and then G generator we get the generated x. Is on real y, and then we train discriminator. Maybe it should work, guys. Guys, we are almost finishing, guys. Alhamdulillah, we are almost. No, not this one, guys. Python CGAN. Let's go. One code input must be tensor, not integer. Where? 101. Weather is awesome outside, guys. I remember when I say tensor 1, right? 30. If I use this one is different, see? Okay, yes. Yes. Let's go. Okay, we have small problem. Runtime error. Matrix 1 and matrix 2 cannot be multiplied. Okay. 512, 256 and 100, 200. Okay, where does it happen? It happens in XL1. Okay, XL1. Because our noise We said it's 100. Yes, yes. I mean, believe or not, it's 100 now. We have problem. I cannot read this one. But I know. No. Where I have a problem? Where? Okay, we are running discriminator, right? And now it stops in generator. Ah, okay. Guys, this kind of small problems happens all time, and you need to have very good, mm, patience to tackle it out. So what was the problem? Problem was that if I don't use this small, just one comma, otherwise Python will think it is integer or it is not a float. It's not a tuple. Okay, when we are training generator, we give to model x and y. Then in L1, we got long and float. We need to have a float. See, float. We need to have a float. This y is dangerous because if we don't convert to float, then our torch is crying, kind of. What else? I mean, we may have another problems also. Okay. Torch and then mock y. Get noise. Oh my god, 144. 144 means 144 is a number of number of images, I don't want to use this, guys. You know, I respect. We need some kind of use this kind of delays, but for now, guys, for now, I don't want to make simple things complicated. Okay, look. If we have 4599, it is kind of decreasing, and 28. 4599. I mean, is it decreasing? 4599. It's decreasing, but it's decreasing very slow. Let's check the learning rate. What kind of learning rate they used here? Stochastic degrading descent, mini batch of 100. Initialize learning 0.1. Learning rate is 0.1. In our case, learning rate is very slow, very small. Decay factor. What kind of magic number is this? 10004. We have dropout, but I am not using dropout. Let's check the results. Let's check the outputs. Now we need to be careful. We should think about it carefully. Okay, I'm using Adam, stochastic gradient descent. Exponentially decreased down to 0.00001. Exponentially decreased. Okay, it means for next epoch I will check exponential of the number. We don't have betas here. In stochastic gradient descent we have torch optim as stochastic gradient descent weight decay. Weight decay. One, 2, 3, 4, 5, 6, 4. Six, 5, 6. 6. Okay. So this is done. Learning rate done. This is done. Oh, this is. It is 4, guys. One more, one more. Oh. And exponential decrease. Zero 0.5. 0.7. X. Our result is ugly. Look to this one. No. My screen freezed. Okay, now you can see, right? This is nothing. I mean, there is no number. It means it's not working. It means our model is bad. Decay rate. Momentum is set. Then so this is formula. New learning rate is equal to new learning rate minus, no, not minus, initial learning rate times exponential torch dot exponential of what minus delta decay rate. Epoch plus 1. My epoch starts from 0. It means plus 1. Okay. New learning rate is equal to this one. No. I don't know about new learning rate. I need initial learning rate 0.1. And then new learning rate. Okay. Decay rate. No? Let's try it out. So initial rate is 1, and then we say torch exponential rate, and then we select minus decay rate, means minus 1.000004, and times epoch 1. Okay. Can I use mass exponential then? Actually, exponential means e power n, right? Exponential means e power n. Exponent of 1 means just the number itself, right? Mass dot exponential 1 2, yes. That it's e, number e. If I make it 2, it will be maybe 5 something, 5 7, okay, yep. Now 0.03. Okay, from 0.1 we are going to 0.03. Okay, but isn't it big change, guys? Isn't it big change? Look, we have first 0.1 and 0.03, and it's decreasing so dramatically. I think it should not decrease that much. 0.123451 means what? 1 e minus 6, right? And if I say, well, let's say like I train it for how many epochs? What's the size of epochs, guys? Epochs, do you mention it? If I use 100, it will be minus 44. It means very, very dark, minus, negative places. So I would say exponentiating. I mean, this is good trick. I agree, this is good trick, but for our case, it doesn't work that much well. So it means we should not update at every epoch. Maybe we should update every certain epoch. One good thing is that let's reduce the number of epochs. Anyway, like it will be not a big deal. Okay, we have a mass, and then import mass. Okay, done. Then what I wanted to do, other things. I have this SGD, right? So in this SGD, I am using this weight decay. Then should I remove it because I am using manually? And how does it influence? Momentum, gradient, velocity. So maybe let's remove, guys. Let's remove it. I'm not sure, but let's remove, because I want to play safe. I don't want to get stuck with this stuff. So let's go with CGAN. However, I updated the learning rate, but who knows? Let's see. So it is 49.51. I forgot dropout. See, now it's not decreasing. It's not decreasing at all. Learning rate is not decreasing. It's bad. It is bad. So where can I put the dropout? Just open it, open it. So where we can put dropout? Okay, we have dropout 5. I put only 1 dropout. But exponentially decreasing is bad stuff. I don't like it. Because exponentially it's decreasing it's decreasing very much. Huh?
The problem is with learning rate decay.
So what to do?
Fix that one.
Yeah, how to fix it? I mean,
Just think.
guys, what about if we update not at every epoch, but update at every 10 epoch? Let's update at 10 epoch. No. I mean, this is not big deal, guys. We will fix it. Just this is kind of bag. $23.08. $23.08. No, it's not learning. It's not learning. The model is not learning at all. What about if I do iteration just like, let's say 10? See, it got stuck. Loss is not decreasing. Got stuck. It got stuck. Okay, page size is our is 60. Our is big number. They use page size 100. We will use. Let's use 100. Okay, let's just go with one. The first one, that is discriminator. Okay. See, it's decreasing, but it got stuck. It's decreasing, yes. Discriminator is decreasing, but at certain point it got stuck. So I'm thinking maybe I have some kind of problem with my output. Okay, okay. I see output is bad. Output 240. So what can we do? I mean, that is a problem. Besides that one, there is no problem. Okay, but I want this 240 to be, very small number. Let's read from here. Log likelihood using 8. What is this one? Here's a formula. Number of samples. Norm. What is norm? So what does it do? So this one is said compute Gaussian kernel value squared unsqueeze. Why unsqueeze? And you see it return as a mean density estimation. Look, if I want to use this one, window text shape. So here I need to give x. And what is x? X tensor of point at which to evaluate the density. Which trained adversarial net and on nets and a range of dataset on a range of. The generator net used a mixture of rectified linear activations and sigma activations, while discriminator net used max out activations. Okay, dropout was applied to training in the discriminator net, while our theoretical framework permits use of. Wow, this is strong. Theoretical framework permits to use the dropout and another noise at intermediate layers of the generator. We used noise as an input to only a bottommost layer of generator network. We estimate probability of test dataset under PG by fitting Gaussian Parsean window to the sample generated with G and reporting the log likelihood under that distribution. The sigma okay. Okay, we fit output of G to this Gaussian Parsean window. Okay, so instead of samples it will be our model stuff, and then training samples. Yes, that is our model, points at which to evaluate the density. Number of eval of samples. We need to understand. I'm not getting this one. How to do that? What is D? Why D is 2? Why D is 2? Why just not another value? H is equal to 0.5. Yes, because our model outputs continuous values, and they propose in original paper also to use this Gaussian Parsen window to sample generate G and reporting log under this distribution. Where I can find it. Let's go to let's check the GitHub again. No, I just need just GAN. Where is the block? I'm not interested in this one, but I'm interested in the output. No, he's not using that one. He's not using the Parsen window density. Maybe let's go. Maybe does he have CGAN, cycle GAN, SOGAN, BGAN, SGAN, maybe DC GAN? I mean, it should be not that difficult, right? I mean, I'm also getting the same values, but I need perfect. Maybe I'm missing something. But it's almost same as previous one. Look, let's go to CGAN. Let's see on CGAN what's happened here. 6 years ago. I mean, let's modify CGAN, guys. Let's say okay, 138, 134, 13. Okay. It got stuck. It got stuck. I'm having a big. Why why discriminator got stuck? Because it cannot differentiate? Zero 0.5 on flatten. I think because of this max out. I mean, if I change this max out, if I change this one to something new, but new, guys, what if I change this max out implementation to something better, something new, some kind of alternative thing? Now what if, guys, I say official one. torch.cat xy xh dimension 1, and then out equal to self.xy max out 1 x and y, and then okay. Mhm. I understood, guys. Yes, something wrong, definitely. What can I do? Okay, why learn loss is not decreasing? Because real out. Because output is always same. If output is always same, then there's no change. Why output is always same? Because input is same, no? it's different, yes. Wait. How I am giving the data. Just wait. How I'm feeding to the model. Get real data. No, this is random. Use your own, brother. Use that one. Okay, I am confused, guys. I'm confused. The problem is simple. Problem is that our loss is not decreasing. Done. Yes. So our loss is not decreasing because it got stuck. Because of what? Because of model. Real out. The all and zero sum. No, like let's say why loss is not decreasing because weights are not updating. That's the cause. That's the reason. Why it's difficult? Why it's difficult and I sing so many hidden gems. It's gem. Because of sigmoid. I think it's because of sigmoid, you know? Of course, because of sigmoid. Sigmoid makes everything static, maybe. Goodbye. It crash. It goes infinity. It goes up. Loss goes up. I think it's because of that one. Okay, guys, I think I found the problem. Leaky radio, lots of max. Radio, linear layer, and then lots of max on x and y, on hxy. Flatten, yes. Linear, yes. It's going up and up and up and up and up. Just going up. I think dropout doesn't make sense here at all. This makes sense.
Maliyelde initialization'da
Then
batch size'da
lock.
learning rate'da bo'lishi mumkin.
Logs of max.
Backward'larda deydi, to'g'ri yozmagansiz. Bu narsa nonsens. Faqat o'rganmayapti. Activation function'da vazifasi kichkina qilib beradi xolos. Normalize qilib beradi. Non-linearity'dan nimaga o'tkazuvda bas.
I think it's because of the sigmoid. I don't like sigmoid. Maybe sigmoid. My roommate is smiling, laughing at me. Okay, 10H, 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 10H. Okay, this is loss. Loss. -0. It's increasing. It's increasing. No, it's not a problem. Where is the problem?
Random no problem.
Initialization?
Yes.
Initialization. Let's check initialization. But initialization should be fine. I'm using uniform. Chi-mean uniform and bias is equal to 0. Uniform means the mean is 0 and standard deviation is 1, right? No? Uniform. Uniform distribution. Uniform means all is equal. No? Yes, uniform means all is equal. Means all is equal and less than. Oh yeah, all is equal, starting from the same point. Starting from the same point. And I don't agree with their learning rate. It's too rush. Okay, okay. Yeah, it works. Now it works, guys. It was a problem with learning rate. Learning is rate high and high, and they put high, but I lowered it. What's happening, bro?
I mean, you should follow my advice. I told you here. It's not with sigmoid laws. It's with learning rate or the initialization.
I mean, we are now using, how can I say? We are now using the idea of uh, using the condition and using this y. But beside that, we are not using this max out. We are not using the learning rate equal to 0.1. And if we talk about real re-implementation, we couldn't do it, guys. It's like 3 hours and we failed to do that, unfortunately. But max out, why it's not working max out? Max out. Maybe there is something I'm missing. I didn't get. But on implementation on GitHub, we also see that they also didn't do it that much. They didn't do that. So let's see the images. So we need to go to local. No. Let's go to the user and then to the actually bishik and then GAN. And then maybe we can see images. Just a moment. Yes, now I mean you can see like this is noise, epoch 1, epoch 2, epoch 3. It's going, but all are same. I think the generator need more. No, I think discriminator need more power. But we cannot say for sure. Because indeed our discriminator is very small, very weak. They're all same. Why is they all same? Yes, now you can see it's not decreasing from 138, and another guy also is not decreasing. So it means they got stuck. They got stuck. So the reason maybe I'm assuming is that model size is very small. I'm thinking maybe instead of 100, let's give, let's say, 256 guys as previously. I think guys, learning rate small. No, it's too big. Hmm. Yeah, we did very big change. I mean, not big change. I would say we did very serious move, risky move. Good idea would be for us is, you know, to to do one small step. And I think ReLU is problem. Leaky ReLU. Leaky ReLU. And why 1000 for this guy? I think, you know, this guy deserves 1000. This guy deserve another. And learning rate. Learning rate, let's decrease one. Let's make it 5. Let's see it. Okay, it's decreasing. Slowly. Okay. Huh? Where? Okay. No, brother. Anlayacağım. Tandır kuşum yedi. Look, all images are same here. Why is that same? So the model should work in such a way that when we give this y condition as some kind of value, it should trigger these linear layers in such a way that they will generate this number. You know what I mean? But here they're all same. Okay, guys, this today's stream is unsuccessful. We failed to produce, but basically, I mean, code is working, but CGAN is not working. Okay, I need to continue my day, so have a good productive day. Thank you very much.